All objects emit infrared radiation, and the characteristics of the infrared radiation are primarily dependent on the temperature of the object. One of the unique features of QWIP technology is the ability to what we call band gap engineer, and that is we can spectrally tune the QWIP detector to respond to certain wavelengths. One of the steps in developing a flight instrument, there's really a sequence of steps you have to go through. Obviously, you're going to develop it and test it in the lab. But then the next step is to really take it to the field and test it. And the step after that is to try and get it into an airplane and test it there. I mean, these are all small steps that are necessary to qualify it to be launch worthy. This process can really take many years. We look for applications, and many of them are science applications, where our cameras can be tested on the ground. And one such application is we've collaborated with the U.S. Geological Survey. They have great interest in trying to find caves on Mars. And one of the features we think that a cave might exhibit is the cave entrance, the opening. We expect it, since it's sort of tied to very deep in the ground, to have sort of a stable temperature. And by doing that, we could watch the thermal contrast of the cave change relative to the environment from daytime to nighttime. So we've sort of verified that this would be a good technique, perhaps, to find life. So we have to figure out how to locate caves before we send probes to look for life, and this is an application. In order to convince people that that technology was mature enough for a space flight mission, we convinced them by showing them our 1 million pixel array, and then they felt confident that the 300,000 pixel array, was a pretty low risk endeavor. So this latest development for the Landsat data continuity mission, the instrument's called TIRS, the thermal infrared sensor. We're interested in wavelengths that are between 10 and 13 microns. So my hope is that someday, this will find its way into, an environment where it would be useful medically to look for thermal pollution in rivers, monitoring food spoilage, residual hotspots after forest fires, pollution, obviously looking at volcanoes. Development over the years that we've been doing ultimately led to the validation of this technology for a NASA spaceflight mission. That's a very hard thing to do.